Swayam Prabha. Digital India. Educated India.
Now again we will continue with the number of tests required. So in any test, the number of individuals to be tested will depend on mainly two factors. One is the variability of the material, and next is the accuracy required from the measurement. So if you need more accuracy, we require larger number of samples. So for many standard tests, the coefficient of variation is known to be approximately, so this is, it's known approximately, so that the number of tests necessary to achieve the given confidence limit and the errors can then be calculated. So we can calculate based on the variability of the material. Now try to test. The yarn has the mean strength of 20 gram per tex with a standard deviation of 2 gram per tex. Okay, mean strength is given and standard deviation is given. What will be the number of tests which must be conducted so that at 95% confidence level, maximum error of the estimated mean will be 1.96%. So the mean is here 20 and 1.96% is the maximum allowable. So first let us calculate what is the value of 1.96 of 20. So 20 mean strength and standard deviation is given, 2 is the standard deviation, and maximum error percent is given 1.96%, and we have to calculate the number of readings, number of tests. So the actual value of the maximum error is 1.96% of 20. So this is 0.392. 0.392 is the actual error. Now through the sampling distribution curve, this is the mean value and our sample mean is the population mean, sample mean is that this is the sample mean, this is the actual error D. And this D, what is this D? As we know from earlier numerical, it's nothing but T into SE. The maximum error is T multiplied by SE, and we are talking about the 95% level. So T becomes 1.96 and AC of standard error of mean. So standard deviation by under root n. Okay, and standard deviation is known. So we have all the data, standard error. So limit of mean is that maximum error is given 1.96% is maximum error. So maximum error will be 1.96% of 20, which is 0.32392. This will become 0.392. So from there we can calculate the standard error. So what will be the standard error? Is 0.2 is the standard error. Okay. Now standard error of mean is standard deviation by under root n. Standard deviation is given as 2. So from there we can calculate the n value. N value will be 100. So under root n is 10. So n is 100. So here the problem is that here the problem was that 95% confidence level, 95% confidence level and 1.96% of the error. Now let us try to change the data a little bit. Let us see, we want to have 99% confidence. 99% confidence we want to have. So the main changes will be here. For 99% confidence level, everything will remain same except (1.96) become 2.58 because of 90. So if we 99% level from T table 2.58. So 2.58 so maximum error was same. So 0.392 divided by 2.58. 2.58 0.15. So earlier it was 0.2, so here it will become 0.15. Okay, this is a standard error. Now standard deviation of population was given 0.15. So n will be under root n will be 2 by 0.15. This is becoming 13.33. N will become 177.7. So if we want to be 95% sure, then we need to have 100 data. But if we want to be with the same confidence, same error range, if we want to be sure that the error will be within that range, so we need typically 178 data. 177.7 means 178 data point we need. So that means number of test data, number of test is dependent on the level of confidence. So if you want to be more confident, we need to have higher number of test data. Now, so it's another way. This is 1.96%. Now, what we want to be to have error of 1.25%, not 1.96%. We want to reduce the error. Okay, reduce the error percent in our estimation. So to reduce the error, we have to test the more and more sample. So as we have already discussed, so if we increase the number in the sample, our error percent will reduce. So instead of 1.96%, here we are trying to do it 1.25%. So it will become 20 multiplied by 1.25 by 100, 0.25. Okay, so 0.25 is the maximum actual error. So here it will be 0.25. So 0.25 is the error, and level is 95%. Error is 95% confidence level. So 0.25. So standard error will be 0.127. So from there 0.127 is the standard error of mean. So standard error we have got this is the what is the value we have got 0.127, 0.127. So n will become under root n will become 15.7. 74. So n will be 247.7 or 248. So earlier with 1.96% error, the number of data needed was 100. But when we try to reduce the error percent in our estimation to 1.25%, error is allowed. In that case, our number of samples to be tested will become high, 2.4. So we have to increase the number of sample tests. So this is important for our research purpose. So those who want to be accurate in their the experiment, so you have to test more and more data. Okay. The next numerical is that the yarn has mean strength of 20 gram per tex. 20 gram per tex is the mean strength of the yarn with a standard deviation of 2 gram per tex. 2 gram per tex is the standard deviation and mean strength is 20 gram per tex. What will be number of tests which must be conducted so that 99% confidence level, the error of estimate of the mean strength is 1.96%. This we have already done earlier. So let us see. So we have explained everything. So we will get the data here at 178. This we have already done. Next numerical is that 44 leaves of 38 any yarn were tested and the mean leaf strength was found to be 55 pound with standard deviation of leaf strength is 7 pound. 7 pound is the standard deviation of leaf strength. Okay. How many leaves must be tested in order to reduce the error of the leaf? Half of the present error, both 95 and 99%. This problem we have already done earlier. So half means that 55 pounds, 44 leaves. When we are trying to reduce it to half, that means at present it will be 4 times of the present one. So 44 into 4. So this will become 177. 176. It will become 176. Let us see. So this we have already done, and this will be valid for both 95% level and 99% level. So we can do calculation, keep on doing calculation, and ultimately we will get 176. So the steps we have already done, these steps we have already done, and the similar numerical we have done somewhere else where 1/4 we have mentioned. So and 1/3 also we have done. So this is half, and this will be true for the 99% level. Level doesn't matter. So here all the steps are same as that earlier. So let us see quickly the steps. So first what we are doing, we are at present the error of mean we are calculating. This is the error of mean based on the present number of sample, okay, where at present it is 44. So the error percent at present is 3.76%, and we want 1/4 of the error. So new error will be, so new error is E2. As per the given condition, E2 is half of E1, that is 1.88. Present error was 3.76, and at present that new error should be 1.88. So the error percent is that at 95% level. So T multiplied by standard error, new standard error, okay. So this is the, and this is the error, and divided by 55, which is the mean value. Mean value is 55 was given, and percentage wise it is calculated. So AC2 is standard deviation by under root n. So from there, if we solve, we will get the n value 176. Similarly, for 99%, following the same steps, we will get the same value 176. Okay. And our next numerical is that 99% confidence range of mean yarn strength based on 70 test sample is plus minus 6. So plus minus 6 is the confidence range. What will be the number of test of samples required to obtain 99% confidence range of plus minus 3? We have to reduce it to half. Error is becoming half. So SD is not known, standard deviation is not known. So 99% confidence range is plus minus 2.58, which is T value multiplied by standard error, okay, and which is given plus minus 6. So this becomes 6 in present situation. So if we try to solve, we will get standard error value. This is the standard error value. Standard error is standard deviation of population by under root n. N is the number of sample. So number of sample is given here, which is 70, it's given. So we can calculate, we have to calculate first standard deviation. Standard deviation is calculated from the number of tests and using the error. So standard deviation is calculated, and for the same standard deviation will be used for the limit plus minus 3. So we can see here the plus minus 3 T value, it's for large number of sample, standard area new. So new standard error becomes 1.16, okay, and the 1.16, so standard error is standard deviation by under root n. So standard deviation we have already calculated using earlier condition. So 1.16 and 19.45 by under root n number of sample under root n is there here, so which is actually the number of sample, and 19.45 we are using the same 19.45, and from there and 1.16 we have calculated. This is the standard error, okay, standard error, and from there we are calculating it's a 281 and if we see present error is plus minus 6 and new error is plus minus 3, that means it will be half of the present error. So from the shortcut 70 multiplied by 4 approximately 280, but always it's not, it will not be, because this is for this type of numerical we can easily get, but we must always try to do all the steps, because if someone says that, now try to see, now let us calculate the standard deviation. What will be the standard deviation of 99% confidence level, of confidence range of a mean yarn strength based on 70 test is plus minus 6. This is not there. Suppose this is the question, and what will be the standard deviation of mean. So 99% confidence level is only given plus minus 6, and standard deviation you have to calculate. So for that we have to do all the steps so that we can get the standard deviation. Standard deviation calculation is important. Rest of the things are almost same. Now next numerical is based on critical difference. We have discussed the critical differences earlier. The recommended number of samples to be tested for least strength is 40. 40 is the recommended number. For 40 samples, the table critical difference is 2%. The new number of sample to be tested, if the critical difference is increased to 2.3%. So critical difference, the table critical difference is 2%, and the critical difference has increased to 2.3%. What will be the new number to be tested? So this relationship we know, new critical difference is equal to table critical difference, which is given in the table, and multiplied by n1 by n2, the root over n1 and n2 to the power half. So using this simple relationship, the 2.3 is the new critical difference and the table critical difference is the 2. So 40 is the table value, the standard value, and new we can calculate, which is 30. That means if we want to test, so standard was given 40 tests you have to do, because for our present case we don't have that 40 samples. We want to be quicker. So if we want to test only 30 sample, not 40, so instead of 2 critical difference, we have to consider critical difference as 30. That means if you reduce the number of sample, here difference you have to consider little bit higher. Now another similar problem, 95% confidence range of mean based on 32 test sample is plus minus 4. What will be the number of test sample required for 95% confidence range of plus minus 2? It's same as, so it will answer will be 32 multiplied by 4, 2 square, 32 multiplied by, because it is a half, plus minus 4 to become multiplied by 2 square. So it will become 32 into 4, 128. So this can be done through the calculation. So you can see the calculation. So that confidence interval of mean is 95%, that is plus minus 1.96 in the standard error of mean. So this is the range. So error is total, error is this one, so 4. So standard error of mean is becoming 2.040, 4 by 1.96. so n1 is 32. So standard error is standard deviation by under root n1. So this is the standard error. So we can calculate the standard deviation. So standard deviation becomes 11.539. So this standard deviation similarly we can use in the next case where it has become half, the error has become half. So standard error of mean becomes 1.02. So new standard error is 102, and n we can calculate from there. So standard error by standard deviation by 1.02. So under root n2 equal to 11.31. So it is becoming 128. So directly we can use, but one must understand the steps, what is going on. Okay. Now this another problem. A large number of ring bobbins were selected from a population of 1 million bobbins of 40 any single yen. If the confidence interval of standard deviation, it's not mean, we are talking about the standard deviation of count, is found to be 4.5 and 5.6. The number of bobbins to be tested is So to have this confidence interval, so our confidence interval is 4.5 to 5.6. So within that, so first thing is that if we want to calculate the standard deviation of population, this is the confidence interval. So confidence interval means it is actually equal in its within that zone. Within that zone, the midpoint will be the standard deviation of population. Okay. So what is the standard deviation of population? 4.5 plus 5.6 by 2. So mean will range between the actually the population standard deviation will lie within the this confidence interval at the midpoint. So mean the mean of this is the standard deviation. The value is coming to be 5.05. So 5.05 is the standard deviation that we have calculated, and it is based on the 99% confidence level. So mean we have calculated, then the error, maximum error will be, we can 5.6 minus 5.05, that is the maximum error is there. So it will become 0.55. This is the error. Okay. So in this way we can calculate. So the t values are given. Confidence interval at 99% level is 2.2 plus minus 2.54 into standard error of standard deviation. This is the standard error of standard deviation. This is the total error. So we can say 2.58 the standard error of standard deviation equal to 0.55. That is the error percent. So 5.05 is the mean we have discussed here, and the error is 0.55 in one side. So this will be equal to the 2.58 by standard error of standard deviation. So from there we can calculate the standard error of standard deviation, which is 0.2131, and if we know this, then we can calculate the, if we know, and also we know the mean value. Standard deviation of population we know, because mean of these two values, and n has to be calculated. So 5.05 divided by under root 2n, as it is standard deviation, and which is equal to the standard error. From there we can calculate the mean, the number of sample required to be tested. So this is 280 samples we have to test. Okay. Samples we have to test for number of bobbins to be selected to get this confidence level. So if we want to have more confidence, if we increase the range, that means number of samples will be required more. Now we have reached almost in the last stage of our discussion here. So last numerical on sampling. So 95% confidence range of mean ion count based on 25 test samples is 3 plus minus 3.2. If t values are 2.58 and 98 respectively, the number of test sample required to obtain 99% confidence range of plus minus 2. So here the thing is that one is 95% level with plus minus 3.2 confidence interval, okay, confidence range is given, and what is required, the number of test sample required, and where 99% confidence range is plus minus 2. So the changes are at two levels. So let us see the, so SD is not known. So we must first calculate the standard deviation based on the first condition, initial condition. So initial condition was there 95% confidence range. So that means 1.96, and 3.2 is the range standard error of the mean, and standard deviation we have got 8.13. This standard deviation will be used in the next stage. So for limit mean of plus minus 2, earlier it was 3.2, now it has become 3 plus minus 2, but the level confidence level is 99%. So for that t value has become 2.54, and standard error we calculate. So standard error has become 0.775. 0.775. From there we can calculate the number of readings using the same standard deviation. So the number has become, so under root n will be 8.13 divided by 0.775, which is 10.490, and the value becomes 110. Now the idea here is, in this numerical, we cannot always simply multiply by square of the type. So depending on the earlier problem was a simple problem, so the complexity will always come. So basic idea is that we should always try to the basic understanding. Okay, we should try to follow the all the steps. So here if we try to do based on the earlier assumptions, that will not be applicable here. Okay. The last numerical is that here it is another small part which we have already mentioned. So a yarn has 15 gram per text with standard deviation of 1.5 gram per text. What will be the number of tests which must be conducted so that at 95% confidence level the maximum error of estimated mean is 1.25%. So same treatment will be there. You can see here the mean strength is 15, standard deviation is 1.5, maximum error is 1.25%. So maximum error actual value will be 0.187, and the limit of mean is this is actually maximum error plus minus 0.187. Okay. (187), and From there we can calculate the standard error of mean. Standard error of mean, from there we can calculate, if we know the standard deviation is known, 1.5 is standard deviation. From there we can calculate the number of samples. So number of sample will be square of 15.79, so it is 249. 249 is the number of sample. Okay. Now in this numerical, suppose we are changing it to only 1% instead of 1.5%. If we change it to 1%, then our number of readings has to be increased, because we are reducing the error percent. So this we have already done. Let us do once again. 1%. So maximum error in the terms of actual value. So let it be in other color. So it will be, say, 1% in place of 1. So it will become 0.15. Okay, it will become 15%, 15, and this is 0.15. This will become 0.15. This will become 0.15, and AC will be, standard error will be 15 divided by 1.96, 0.07. So in place of 0.95, 0.07 is the standard error. Now the standard deviation is same. Here it will become 0.07. So we can get the n value. N will be 1.5 divided by 0.07 square, 459. Sorry, it has become 459. So earlier it was 240. So from 1.25%, if we want to reduce it to 1% error, we have to increase the number of tests, number of reading, from 249 to 459. So this much increase you have to do if we want your data to be much more accurate. So we will stop here. We have already discussed all the aspects of sampling, basic statistics, and the different analytical approaches to solve the practical problems. And in next class we will start with the testing of fiber length and related to the analytical approaches to solve different problems. Till then, thank you.